Hey guys, wanted to talk to you about the idea of a joule, which is something that you're probably unfamiliar with. But the reason I want to talk about this is that when I asked you last class to rank those sports objects based on the amount of kinetic energy, your rankings were often very accurate, even though your values weren't. So, just as a kind of an exercise, would you just take a second and rank these four objects based on how difficult they would be to pick up? Pause if you need to. And now that you've actually taken that time, I'm sure that you were all able to recognize that that TV is going to be the most difficult to pick up. It's the heaviest, followed by the textbook in 2, the hairbrush in 3, the tooth in 4. And I would imagine that that's not very difficult. Now, if you start looking at this in terms of actually coming up with numbers, though, the question is, did you use pounds? Did you use kilograms? Did you use grams? Are you British? Did you use stone? Well, regardless of what numbers you get here, the ranking is going to be the same because these units are all related. Okay. So that's really what happened when you guys were ranking your kinetic energy objects. You were using K equals 1/2 mv squared, but because these units were not in scientific form, you ended up getting different values. And the ranking ended up being okay, but the values that you got were not. And the point is that we didn't get to the correct unit as we had hoped. So let me introduce something a little new. This is saying it's equal to, we have an actual formula, but regardless of the formula, we know that the kinetic energy is proportional to, that's what this symbol means, is proportional to the mass times velocity squared, regardless of units. So with that said, if we use, let's say, pounds, there's going to be some number out here. It won't be a half, but if we use pounds and miles per hour, the kinetic energy will actually be this times some number. We don't know what it is. If we use, let's say, grams and kilometers per hour, we're going to get a different number. So this might be K sub 1 and this might be K sub 2. The only way that we get that 1/2 there is if we are using the classic scientific units. So when we use kilograms and meters per second, that's when we get that 1/2 value. So even though your ranking was correct, if you didn't use kilograms and meters per second as your units, your values weren't correct. Now, I just want you to take a peek at that right there. We've got kilograms, meters squared per second squared. Well, when we look at that, this is an awkward unit to continue writing over and over again. So we actually want to get started learning how to manipulate these units. Kilogram. I can see that this is really just 2 m's. And I'm hoping you can see that that is, hey, come back, is just a Newton. So this would really be a Newton meter, which is easier to write. But when we're talking about energy, we are often going to convert that to 1 Newton meter is 1 joule. Okay. And 1 joule is equal to 1 kilogram meter squared per second squared. And we use the unit of capital J.